Assalamualaikum. My name is Muhammad Adin bin Mat Lazim from section 4. Today I'm gonna tell my topic, which is schedulability analysis on Agri UAV using enhanced utilization approach. So the content is, the first is introduction, background, case study application, discussion and conclusion. So what is Agri unmanned aerial vehicle? The project scope included the research of researching and learning as much as possible about Atasia Agri UAV system and all its guiding principles, from how it can be used to its criticism and risk to how it can address issues that learning process. The proposed system to create a management framework that will enable farmer to operate more profitably. This framework will make use of drone or unmanned aerial vehicle, which is UAV, the short form is UAV, to sketch much larger area, allowing for more accurate observation and planning for future land usage. Additionally, doing so enable the landowner to make the most of the land potential for agriculture use. As for the image was captured was an aerial perspective, user may enter into the system and access all specific detail about their area. So scheduling analysis using processor utilization approach. Schedulability analysis is used to examine if a certain set of work or a collection of tasks that satisfies certain criteria can be scheduled efficiently. Utilization technique in schedulability analysis will be employed as it thought to be one of the highly efficient schedulability analysis, since we required a highly dependable and real-time communication to improve the overall system performance. So background of the existing schedulability tool. So I find three tools that we can use, which is ScaleLab, Cheda, and MAS. ScaleLab is based on time scheduling algorithm for managing multi-processor and multi-reticle control architecture of any level of complexity. For Cheda is GPL, real-time scheduling tools or simulator that enable users to simulate the software architecture for real-time system and assess their meet other performance requirement or can be scheduled. MAS is a tool for real-time distribution system to do schedule analysis that evaluate a wide range of timing requirement. So the schedulability tools that I'm using is ScaleLab. It will be utilized since it can create a timetable of how job will be scheduled and run a schedulability test utilizing process utilization analysis. So the case study, the research paper one that I found is a multi-processor scheduling problem is efficiently reduced to set a single processor scheduling problem via Petionet scheduling technique, one to each processor. Thus, using the finding from the theory of uniprocessor scheduling, it is possible to determine the worst case sequence of job that can be produced by particular sporadic task system. With the task system being scheduled, if and only if this worst case sequence of job is scheduled successfully. A method based on the ideal predictable scheduling algorithm to simplify scheduling testing for global multiprocessor scheduling. So the research paper 2 is about utilization of bound test and reaction time analysis are the two basic schedulability analysis method for single processor system. Since there is no method for exact scheduling analysis for multiprocessor system comparable to the response time analysis algorithm for single processor system, it is necessary to rely on utilization bound tests that are safe but pessimistic to determine the schedulability of priority-driven periodic task set on multiprocessor system. By modeling the real-time and multitasking system using Teammate Automata (TA) and the converting the scheduling analysis problem into the reachability checking problem of the TA model. Model checking is used to give a method for precise multiprocessor scheduling analysis. So this is the SA approach to the agri UAV. The task there are 6 tasks, which is flight landing, avoid obstacle, scanning area, adjust altitude, taking picture, and communicate. So and this one the enhanced SA approach for the agri UAV. So discussion, the outcome demonstrate that the CPU is being used to the same extent across the board, while the basic SA approach utilization value are inconsistent and underutilized. So the conclusion is, as a result, it is clear from the that employing research methodology for aggregate consumption control will keep utilizing below the schedulability constraint to develop a probability guarantee on meeting both deadline. Statistical component of the task driver process can be combined with mathematical analysis of feedback and control loops. So that's all from me. Thank you.